Hello guys, and welcome back to the channel, and welcome to our third and final installment of our Introduction to Proof for AS Unit 1. Today we will be looking at disproof by counterexample. We've already covered proof by deduction and proof by exhaustion. Both videos will be linked in the description, and I highly encourage you to go and watch them just so you get a little bit of a greater understanding for those two as well. Alright, so without further ado, let's get into it. Alright, and as normal, we shall jump straight into it with our definition. Alright, so our definition is to find one example to prove that a property, i.e. an algebraic expression, does not work. And this is where disproof by counterexample differs from proof by deduction and proof by exhaustion. For our other two proofs, we are proving that things are true, and that is where we needed to show that all possible cases are true. But for disproof, we only need to find one example that proves that the statement is incorrect. Okay? And so don't waste your time trying to find more than one example when you have a disproof question, because more often than not, the expression given will only allow for one example to not be correct. And you'll soon see shortly. Okay? And so we shall start with our question. And so our question for today is to disprove by counterexample that x squared minus x plus 5 is prime. And they will more often than not look like this. Okay. So disproofs are often worth the least number of marks. And this is because it's generally quite a lot more straightforward than proof by deduction especially. And disproof by exhaustion to a certain extent. And so for this, you will often find counterexamples as part 2 to a question. So if you've got a proof by deduction question, it might at the end say that there's a caveat in that something won't work if these parameters are in place. And that is often when disproof by counterexample is used. It's very rarely used as a standalone question because these can often only be worth 1 or 2 marks. But there are 3 steps involved. And so for the first step, we have to demonstrate results. And what this means is just showing that for the majority of the time, this statement here is true. It's a bit like going to court. You are classed as innocent until proven guilty. What we do for these types of questions is assume that this is true until we find our counterexample. And for that, it's really nice and easy. We just plug in 1 or 2 different numbers to show that this statement is true. And so we'll start with that. Okay, and for our first demonstration, we'll let x equal 2. And so when we sub in, we just make sure that we put brackets around our x's to show that we are substituting in this value here. And as you can see, it's 7, which is prime. And so we'll try a second example. Alright, and so for our second example, we'll use a negative number just to show that you're varying what you're doing. Don't forget negative numbers are also integers. I should have put this by here. But whenever you've got values like this, they more often than not mean that you are using integers, so don't bother with fractions or decimals, okay? And as you can see, when we substitute in -2, we get 11, which is a prime number. Make sure you show your workings out for all these, just so you ensure that you're getting the marks. Okay, and for our second step, and that is to find the counter. And you could go about this by just subbing in random numbers into this expression here until you find a number that isn't prime. But there's often a much more efficient and mathematical way to do it. Okay, and we'll have a look at our friend, the x squared term here, because this is really important, as this is the only term in the statement that can ensure that a number will never, ever be prime no matter what you substitute in. And that obviously makes sense, because if you square a number, the square root of that means that it's not a prime. Okay? And so, if we now have a look at our second half, we have got -x and +5. If this means that we can get a number that isn't prime, then we must have to find a way to get this to cancel out. And it's quite obvious which number it's going to be. And that is if x is equal to 5. So if you substitute in 5 there, you get 5 squared minus 5 plus 5. This will cancel, so all you're left with is 5 squared, which is 25, which of course isn't a prime number. And so we'll just write that out very quickly. And there we have it. All we have to do is just write it out the same way as we've done above. You don't need to go into as much depth as I did explaining it. It's just for you to nice and clearly see what is going on in order to get a value that isn't prime. Okay? And so for our third and final step, we have, of course, if you've seen the other videos, and that is, of course, to rewrite the initial statement, which I've done here very briefly. But don't forget at the end to include and there we have it, disproof by counterexample. And that means that we have completed our introduction to our proofs. If you would like to see more in-depth videos, please do let me know in the comments down below. But other than that, I'd like to thank you all for watching, and we shall move on to the second part of the specification next time. And just as a quick recap, we must first demonstrate the results that we assume are true based off this statement here. So we assume that this is prime and show that some examples do prove that this is true. Then we've got to find our counter. Make sure that you have a nice in-depth look at the sort of expression you're given. It more often than not will look something along the lines of this, but just have a look to see what clues this can give in order to help you find the counter. And then don't forget to rewrite the initial statement again right at the end. All right. And with that, I shall see you in the next one. Thank you. Bye-bye.